Terms and substitution. Solved problems. The first problem. Which of the given terms are free for y in the below formula? The formula is there exists x, left parenthesis b0 x and b1 y, right parenthesis. Let's look at the term x. Is x free for y? So we should pay attention to free occurrences of y. There is only one. And what happens if x is substituted to y? Does it become a bound occurrence of x or not? Yes, it becomes, because there is this, in the beginning of the formula there exists this quantifier, there exists x, which would make the occurrence of x in place of y bound. So the answer is no. Then constant c. Constants are always free for any variable because they cannot become bound, because constants are not quantifiers. So the answer is yes. Then the term is y. A variable is always free for itself. A free occurrence remains a free occurrence because there is no change. So the answer is yes. And z, if we replace y by z, z remains free because there is no quantifier over z anyway in the formula. So the answer is yes. Next problem. Which of the given terms are free for z in the below formula? The formula is for all x, left parenthesis r, x, z implies s, x, z, right parenthesis. First we look at the term y. What happens if we substitute y into z? This formula has no quantifiers over y, so y couldn't become a bound occurrence. So the answer is yes. Constant c, a constant is always free for any variable. So the answer is yes. What about x? If we substitute x to z, clearly the two free occurrences of z become bound occurrences of x. So the answer is no. Finally, z, a variable is always free for itself. So the answer is yes. Next problem. To which of the given variables can the bound variable x be changed in the given formula? The formula is there exists x, left parenthesis b0 x and b1 y. Can we change the bound variable x to z? Yes, there is no free occurrence of z, which would become a bound occurrence of z after the change. So the answer is yes. And the result is there exists z, left parenthesis b0 z and b1 y, right parenthesis. The next is y. Can we change the bound variable x to y? Now if we do the change, then the last occurrence of y, the only occurrence of y, which is a free occurrence, would become bound. So the answer is no. Finally, x. Can we change the bound variable x to x? Of course we can, because it's no change at all, so there's no problem. Next problem. To which of the given variables can the bound variable x be changed in the given formula? To which of the given variables can the bound variable x be changed in the given formula? First, z. Can we replace x by z? No, we cannot, because the two free occurrences of z would become bound. And this is exactly what should not happen. So the answer is no. What about y? Can x be changed to y? There is no free occurrence of y yet, so no free occurrence of y could become bound in the change. So the answer is yes. And finally, can the bound variable x be changed to x itself, which means not changed at all? This is always allowed, because nothing is changed in the formula, so no free occurrence can change to a bound occurrence. Next problem. Show that the implications for all y a implies a t/y, where t is free for y in a, and a t slash y implies exists y a, where t is free for y in a, are not valid if the condition where t is free for y in a is dropped. We will treat only the first implication because the second is similar. Let M be the graph on the left, a triangle, and let S be an arbitrary assignment. Then S satisfies for all y there exists x such that x e y in M. But it is not true that S satisfies exists x x e x in M. Indeed, x is not free for y in there exists x x e y. And this is the reason.